Welcome to SP Smart's NEET Direct program. Today we shall be discussing previous year questions from various competitive exams from the chapter of electrostatics, part 3rd. So let's start with the questions first. N drops each of capacitance C coalesce to form a single big drop. Then the ratio of the energy stored in the big drop to that of the small drop will be. This is a question, but first let us analyze it. You have N drops. So this is the formula which relates the radius of the large drop and the small drop, and is it number of drops. All right. So capacitance of large drop is, as you know, 4 pi epsilon naught into R. Small one is 4 pi epsilon naught into small r. This much you know. Okay. Now, as they're asking for the ratio of the energy stored means, I write here expression for energy half CV square. This is the expression for energy. You can also write it as Q square by 2C. So let me use this formula because I prefer this formula. It's easy to handle this formula. All right. Now, energy of the one single small capacitor, charge on that small capacitor upon twice C. What is the charge? Let the charge be Q, so it's Q square upon 2 times C, और वो small वाले का C हमने ये रखा है 4 pi epsilon naught into R. So 4 pi epsilon naught times small r. ये आ गया energy of the small capacitor. Now energy of the big capacitor. One single capacitor, the tiny droplets which are behaving like capacitor. When I say capacitor, I mean those tiny droplets. One single capacitor made from the droplet has a charge Q. So N will be having charge NQ. So I must write NQ whole square because this is the total charge, right? This is total charge. When they combine, the charge becomes N times Q by 2 4 pi epsilon naught into capital R. Now you have to find the ratio of the big to the small. So I write this way: big and small ratio. That is, I have to divide 2 by 1. So big means n square q square upon 8 pi epsilon naught r into 8 pi epsilon naught small r upon q square. As you can see, I'm using these two formulae here, these two expressions here. All right. Now let's check out what cancels. This cancels, and you are left with n square in the numerator with r and capital R here. All right. This is all right, but now let's find small r by big R. Now the capital R, as you can see in the beginning, is n power 1 by 3 times R. So I should write this thing as n power 1 by 3 times R. These two r's cancel. This 2 minus 1 by 3 because now I have taken this thing from numerator to the denominator. And isn't it? This expression now becomes n power 5 by 3. So this is the answer to this problem, n power 5 by 3, and that's there. C option, n power 5 by 3 is to 1. So when we say the ratio, we can write this as the ratio of capacitance of the, energy of the big to energy of the small drop. And this is C option, which is the correct option for this problem. Okay, now let's move on to question second. It's written that a parallel plate condenser means capacitor. Condenser and capacitor is one and the same thing. With oil between the plates, heavy dielectric constant kappa equal to 2 has a capacitance C. So एक तरीका हमारे पास कि मीडियम की प्रेजेंस में लिखते हैं kappa times C, right? Kappa का value है 2. Let me write here 2, and this capacitance is C. C prime रखेंगे इसका नाम when the oil is removed. So what is the value now? C by 2. That is option D is the correct option. You got the point? सिंपल सी बात यह है, जब ऑयल था कैपेसिटेंस वाज लार्ज, ऑयल हैज बीन रिमूव्ड, कैपेसिटेंस बिकम्स लेस, कापा टाइम लेस, एंड दैट मीन्स कापा हैज वैल्यू 2, तो 2 से डिवाइड करना पड़ेगा, तो कैपेसिटेंस जितनी थी ऑयल के प्रेजेंस में अब उससे आधी रह जाएगी. दैट इज वाई ऑप्शन आई हैव रिटन हियर डी ऑप्शन. So D is the correct option for this problem. Okay, now let's move on to question third. And the question is, what is the area of the plates of 3F parallel plate capacitor? Let me write the formula. C means E epsilon by D. Here C is 3 farad. Separation is 5 millimeter, means D is 5 millimeter. Millimeter means so many meters. All right. And epsilon naught has a standard value 8.856 10 power minus 12 coulomb square per Newton meter square. You put all these values here and see what you get. 3 equal to A, which is unknown. Then you have 8.856 10 power minus 12 divided by distance, which is 5 10 power minus 3. Okay. On simplification, let's see what we get. If I keep A on one side and shift everything to the other side, what do I get? It is 3 into 5 into 10 power minus 3 divided by 8.856 10 power minus 12. Let's simplify it first. Okay, on simplification, this is now 15 divided by 8.856. On further simplification, we get 1.694 into 10 power. You bring it here, it becomes 10 power 9 meter square. So this is the area of each plate. Let's check out which option is this. 1.694 10 power 9, 1.694 10 power 9 meter square. So option A is the correct option for this problem. So in this way we have solved today's NEET direct programs previous year questions from Electrostatics part 3rd. Question first has answer C, question second has answer D, and question third has answer A. That's all for today. God bless you all.